this community with this gathering is so good. So I'm not doing to say this by myself. I was thinking there's a couple of people, right, who has a really important role in the visions and in finally determining the what transport we will get, right? For example, we had the leader of the trade project, leader of the each project index, and we also have the Dan who actually built the transport back 2 years ago. Why you guys come? Why you guys come, right? Please, 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 right? Come, right? You guys have the huge role to play, right? Right? And Keith as well, he was running the company, and he's going to, you know, actively engage all of us on the development. But then so many people, I cannot have everyone. I think I need to have Jay as well, please. Yeah. Yeah, Jay. Jay is big pharma. Yeah, Jay. There's many other people like Jing Lai, but there's too many here. So that has to be. So I think what we really want to do is somehow we have a dialogue, right? Have their view, say, if we've got all the money of the world, Obama will give them anyway. This is a grand job, right? So, and what we expect the transplant to have in 1 year's time, 2 years time, 3 years time. That forget about after 3 years. I think that is out of our. I'm going to retire anyway. So let's say, how about this one? 1 year, 2 year, 3 years. I mean, they have a talk first, and then we kind of dialogue. How about that? We got Avatar. They said what they said, right? We don't care about Avatar now, and we care about this is the group people who have the fundamental influence on the transplant can go. So how about this one? Is it okay? You happy with that? Okay, I'm taking a seat. Yeah. Okay, so I think I will ask Ian go first. He got 27 million in his hand.
It's 24.
Oh, 24 then. 24.
Right.
Yeah, 24.
Yeah, I've got very simple business, and I don't really own the roadmap for e-tricks. The customers do. So we set up e-tricks not as a technology and software engineering project, but as a service project, the IMI calls. And so we will measure those projects. And so the conversation myself and Nikki and the leadership team continually have repeatedly is if the customers aren't happy, that's been a little bit tricky because we've had to deal with a lot of non-functional changes because of the issues we've inherited with moving the transport from Oracle to Postgres. So we've bitten the bullet with some of that, but I still stand by the basis that we don't build anything unless we've got a clear customer line of sight into what they want. And we've got projects queuing up, and this is what's scary for us. We've taken on 5 projects in some level of support right now, and we've agreed that with the General Assembly for e-trick. And now we've got probably 6, 7 more knocking on our door. And so we scaled e-tricks to a scale which we thought was a sensible experiment for the farmer. The amount of money we were going to put in, but it's big enough to do something and demonstrate what you can do with a transplant system supporting translational medicine. But it's in some ways this is starting to catch up with us very, very quickly. And so we've got to keep our line of sight with the customer and what they actually need. And really the primary thing for us is managing their data. The key thing that I might want is that data that's being generated in all these projects. It's primarily the clinical data along with this genomic data is to be archived somewhere and secured. And actually it's not going to disappear after IMI just spent €2 billion on this project, these projects. And that's what they want. And so yes, we want all the analytics. Yeah, we need all the loading scripts, but the key thing is to get the archive and get that data secured and managed across this project. So I'm a little bit worried. So yeah, but it's great to see so many people here, and we're happy. We're going to crack it. So, do you want to go next?
I can give my answer if you want.
Yeah, go ahead.
So on the one hand, first of all, I have both the commercial side of the world to think about. Like, what do people actually want to pay money for? And that's a bit clouding the opinion, which sometimes is helpful. It's probably the same as in some of the major academic projects, which is what are the users really driving us to produce? And we're on both sides in my world. But the things that are a gap in the market become the big drivers for what I think needs to be in the core. And the big gap in the market, what people don't seem to have a good handle on in any group, is this ability to find an analytic place, not a big data warehouse, which I think is covered by lots of different solutions, places to just put all your data. There's lots of ways people do it. In fact, I think that'll be highly heterogeneous. But an analytic mart, so a mart, not a warehouse, where the information can be used in integrative analyses. And the two primary integrative analyses that seem to come up the most frequently, that are really hard, are cross-study analysis. So have information in a model where we can look between various different information sets and different studies, groups generating data from two different healthcare institutions, two different clinical trials in the same compound, you name it. Cross-study is the thing that people can't seem to find a solution for in their repositories for analytics. And the other is cross-modality analytics for being able to get after looking at heterogeneous data types that we keep adding on and piling into, which are not available in a form where we can go and access and execute something to look across a gene expression data set with some VCF data alongside clinical information, which all three were probably necessary to answer my question. And so, you know, the user I'm most excited about is actually the bioinformatician who can write a very nice, elegant application to use those data sets. But the user who's going to buy the system needs to see something pretty. There's got to be a front end and a view into this information that looks like a catalog that they can interact with. And whether they can do real science with it or not, I'm not sure is critical. But they should at least be able to do effective interaction with the data, so they understand the contents of what's there, and then hopefully be able to model some science that can then be handed to bioinformaticians.
Yeah. Okay.
Just can you explain a little bit more the distinction you make between a mart and a data warehouse?
So in a data warehouse, you would bring your information together for the purposes of building lots of different analytic applications. And so you'd be persisting the data in many different forms. And now there's many ways to translate, you know, what's the difference in a mart and a warehouse? People can debate that all day. But in general, the people who are dealing with data warehousing are going to build a distinction between where they integrate and organize data and where they go and run analyses, and that the analytical applications would be somewhat optimized to be able to support things like that. And the reason why I'm separating the warehouse from the mart is from my experience with I2B2. So in I2B2, everybody wanted a cohort selection tool that could give you very easy access to be able to do 100 different things that you could pick a cohort. You could use the cohort selector to pick out which patients you want to go pull a sample from. You could use it to model how many patients would be qualified for clinical trial, what data set the IRB would approve, right? It was all clinical data. There wasn't all these other pieces. And it was very successful as a mart because groups could take it, implement it, and suddenly do all those parts of their workload. But each group had their own local infrastructures for dealing with their clinical data that were complicated, hard to generalize, hard to standardize, both in terms of hardware infrastructure, local content, priorities of content, and most importantly, other things they wanted to do internally with those data sets. So a lot of the groups that are using I2B2 wanted to use that data to do operational reporting. And for us to build an open source platform that does everything for everyone, I think those are two different products, right? The one which is a store for all your data that does anything, and one that's a store that does the analytics. Now we could make both. I would just focus more on the one where there's pain in the market.
Okay. Case? Do you want to say some few words?
No, please.
Okay.
Let the others.
Yeah.
So I can tell you what we're improving in projects. We've had tranSMART in place for about a year. In addition to translational studies, which we have a couple good examples. We also have enabled genome-wide association studies, something that was really needed internally. And we'll talk a little bit about that tomorrow. In terms of the things that I worry about, now that we have approximately a half a terabyte worth of data in our instance of tranSMART, I'm worried about performance, specifically on data loading. And others. So I'll start with data loading. We have probably close nearing 200 individual GWAS sets in. Most of those GWAS sets, many of them, now getting data for an additional 200 that with imputation are numbering 7 to 8 million SNPs. So it's a huge data set that we have to take in and learn about performance of loading and learn about performance of getting that data back. And so that's one thing. I'm worried about scalability. We've been asked to store genotypes. And I'm sure all of our competitors for certain indications are going to pull genotypes for all clinical trial subjects. That is a goal. Where is that going to go? I want to say tranSMART, working with recombinant last year, and we've done all our work to date with recombinant. We set up a pilot where we loaded 2,300 individual genotypes in. And again, the performance on the search was I think less than adequate for what we need to do, and we really need to take a look at that over the next year or so, and see if we can make genotyping work and have tranSMART being a repository for genotyping. Safe analysis, export and grid functionality, those are things on the list. Clinical, so like he said, if we use Oracle for Pfizer, or we use Oracle for Pfizer for a lot of things, but specifically for our clinical information systems, are validated for submissions. And there are use cases where we have clinical trials that have exploratory arms that we need to support the exploratory data with clinical tranSMART. We need to figure out how to bring our clinical trials information that are associated with those studies, but pertinent information for exploratory analysis into tranSMART, and we're working on that this year. Longer term cross-study searching, again, a really good implementation for genotyping that can scale. That can really scale to multi-terabytes. And if that means a highly parallelized implementation, wonderful. Whether it's to do for something else, let's look at that in the long term. In the very long term, the translational knowledge management environment. I think everyone's going to use that. Right? I think that's going to resonate with just about everyone here. I don't know exactly what it means, but maybe it means integration with something like the Bell framework. Things of that nature are things that we're thinking about in terms of actually making these data that we're now collecting actually useful.
Right. That's a question, Dan or Jay. What is the largest instance of transport running like that? Is it yours?
It's either ours or Millennium. I think it's actually ours because Millennium, actually, I'm looking at Millennium here. They've done really great work as Sanofi. And they've loaded, now it's all proprietary, they've loaded a ton of things in from help me out with the
Omicron?
yeah, a bunch of expressions.
CCGA?
Anyway, I'm sorry, I'm blanking. But they've done everything on data curation from expression sets. Brought that all in, and I think it might have been thousands for oncology. And they've also put in the RAPI, and I don't know if they worked with recombinant to implement that, but they've actually implemented an R interface that we use for genotyping.
So what is size?
Well, I also
What
think
is
your
the real
measurement
size?
is,
So the real size of ours currently is about half a terabyte. We will probably be at, I'm looking at Omni here, 700-800 gigabytes or more.
Yeah. So close to terabyte.
By October. So it's roughly a terabyte within this year.
but I think if you're going to measure implementations in the long run, what you're going to see is measure your clinical data store and measure your omics data store. And don't measure it as one big thing, because you're going to end up like, weighing an ant on the back of an elephant and trying to figure out how much the ant weighs.
Yeah.
and it's not going to help you, because you may have a much bigger ant.
Okay.
Right?
So,
With
Greg,
your clinical data.
do you have some comments?
So to actually outline what I would like to see in transport, I think I want to take a step back and see how I would like to have my translational research from start to end actually supported by IT. And somewhere in that spectrum is transport. And that comes down to the cartoon that I showed and that Jeroen showed, and that starts with the patient entering the clinic. A lot of processes ongoing for generating data in 4 domains: clinical imaging, biobanking metadata, and all of the experimental / omics stuff. Then data integration, and then your downstream analysis and visualization. And I think could be perfectly happy if tranSMART would just do that data integration, because that's basically what you were referring to across studies, across but also across those data domains for individuals. That is something that may be different in pharma, when you may have lots of bioinformaticians, but certainly in translational research groups, as I'm running, that really is a challenge to get that in a standardized, quality assured way. And I think that tranSMART could really make a difference there. I think it's a valid question to see whether and to what extent tranSMART should provide analytic features or visualization features, or rather, and that comes down to the vision that Kees also presented, have a core to which tools like Galaxy, Gene Pattern, or whatever downstream analysis and visualization tool could connect. And upstream, where like from the data capture systems we are using Clinica, but there are other biobanking systems, and all of the pre-processing pipelines of the omics data would feed into. So data integration and connecting to the outside world within that pathway of translational research that is key now.
So, have you got a list of different tools that you plug into the transport ecosystem based on the projects you guys are supporting?
Yeah, well, I think I only have a high level view of that. So if I start naming some, then Jeroen and Willem certainly will have additional tools. But electronic data capture, like Clinica we're using, or perhaps having direct links to electronic health record systems. For the omics data pre-processing, that's also a place where Galaxy has a role. So I could see Galaxy upstream and downstream of tranSMART. And then I would say any of the biobank tools, perhaps via the common biorepository model that we're working on. Linda Mock is working on that in the trade project as a kind of standardization interface between the data integration layer and the actual index of the freezer that your samples are in. Because you need those if you want to run the queries and say, well, give me patients that fulfill these criteria and for which I have still samples available.
Yeah. Okay. Do you want to say something, please?
Yeah, so I think what we're hearing from Ian is what we need is data archival. Sort of, very sort of.
That's what I'm hearing from my life. So I want to be very clear why they're interested in it.
And Christoph's Jay is saying we need some kind of performance. We need to attend that and look to that. So that's both very much on data storage level. Dan was making the point that yes, we still need to have some kind of GUI to get end users on board. So I'm again now coming back to the point I'm making all day why we need this core. If you remember from the image, you have this core API in the middle, and on the bottom you have the data storage, and on top you have the GUI and presentation layer, right? It's the classical three-tier architecture model. So what this core API essentially does is it makes sure that if we do a lot of effort on GUI and visualization, and we will do that in projects, and people will work on that, that we can actually reuse that as we iterate the data model and as we address things such as performance, scalability, and so on. So basically what we're doing is we make sure that we have a community where we can work on all these parts separately without having to create the one one and all solution that has everything. But that would be my view on this.
Well, I mean, I guess the question that comes out of that comes next is, well, what is this core? Because it's a amorphous object unless we define what things and classes of things we want it to enable. Because of course we want to have the community be able to develop different things, but it has to somewhat be defined by the same question we're starting here with, which is what is the basis of circumscribed around it?
Yeah, I think you probably lead it to the second stage of the question, right? The first stage, I think, Kate summarized very well from all the comments here, right? Is you have a core, you have API, then you have the surrounding systems, do analytics, do presentation. Core, the biggest requirement, which is the scalability, which is from Ian, from Jerry, is all clear, right? Is scalable.
Well, extensibility is as important as scalability.
Yeah.
And also probably
extensibility
extensibility in a way that we have a predictable store. So
you need to be
if something's too extensible, it doesn't do anything. That's
no,
one of our
from the
problems
data
with
size
ICT.
point of view,
Right.
when I talk about scalability, is only talking about really the size. Now you talk about terabytes, right? And if we talk about 3 years later, probably you were thinking about it. I'm not sure if the petabytes will come to your mind, but it probably will come, right? So I think for the core part, you have a clear challenge we're going to do it. And the surrounding system, which then comes, is really have to see, don't make this core a little bit too dry or too. I'll put the word in your mouth, so I guess if I'm wrong, correct me. I mean, basically, you want the core not have a more than function just to store big data. Okay, so you want to define API in a way so analytical function is actually be supported by the core. That's the word. And then is the third layer is we needed to plug in many tools because God knows what kind of tool will use it. Today, at least here, I counted about 7 different tools already people use outside of the tranSMART, for example, Spotify, right? So I really think is so our next question I want to organize a little bit is let's focus on one question, the core. Let's focus on the core, right? Just the core system. So what is our major technical challenge with the core, right? How actually what does it emphasize? For example, size, right? I mean,
Size is not a concern of
okay,
course.
size is not concerned.
No.
That's the one answer. That's the one answer. Size is not concerned, so we can deal with the petabytes.
Yeah. What the core really is it defines certain expectation and it defines a common language. So for data retrieval, you would specify in the core what type of data retrieval operations you expect you're able to do on the underlying system.
But Jay mentioned that on a terabyte level already, there is a question about the query performance. Okay, yeah. We actually have the same question on Egypt when we first time use the new system. I do think theoretically you have no problems to actually store any data, any size, but you do have the issue here now of performance, which actually can handle their daily use.
Yeah.
Only for simple query.
Really, the problem for defining the core is defining the exact requirements of such data retrieval operations. Right? So how do we expect the data to be modeled? And we could have several models, which you see already now at tranSMART, that you have a model which is specific for searching querying, where you optimize the performance, or you have a model, for example, for the ontology data, which is just getting the data as it comes, and where we don't need to worry about performance because the data is very low in volume. So you could have we have various expectations on how we can get data out of the system, and that's what you define in such an API. And on the other hand, in the analysis, you have the same where you define what you expect of an analysis algorithm or a visualization tool. So you define again there a common language of how data progresses from the underlying warehouse or mart or wherever you call it to the analysis system.
Right. But if I ask you one question here, right? So before you design these data storage systems, what kind of size in your mind now? In your mind, is it a petabyte level or is just a terabyte level that you are support for the system we're going to develop in the next 3 years?
Well, you cannot avoid having that a little bit in mind in the specifications of the API, of course.
And not every problem is API
but
problem, right? It's a very
if you talk specifically, for example, about genomic data variants, yeah, of course we're talking terabytes. There's no question about that.
Well, and I think one of the things that comes up in a performance question is that, there's two ends of the spectrum. There's super integrated systems and there's super modular systems.
Yeah.
And super modular systems end up being fragile and sometimes have performance issues. And super integrated systems are fragile because they're so integrated you can't do anything after a while. Yeah. And so we need to target somewhere in the middle.
Yeah.
When it comes to things that have to have high performance, the characteristics of the API are probably going to have to force a lot more requirements on that subsystem.
Yeah.
Not, it has to be able to figure out, for example, if I'm going to run a GWAS, which is going to take either 10 seconds or 3 weeks, the API has to be able to deal with scheduling and job queues and management. We can handle them all, right? But we have to handle them in the design of the interface for, I'm going to go call an analytic pipeline that looks like this class of, high performance requests versus, lower performance. So we can deal with it.
question here.
Can I just put in a reminder? We're talking about roadmap vision, right? In a sense, we're talking about 1 year, 3 year roadmap. We jump directly into the API conversation and all those. If we don't define the business case or scientific use case really well, it doesn't really matter if actually we create a nice API and then it's not useful for the scientists.
Yeah, sure.
So I think we should actually probably I would recommend we go back to all these avatars and continue those conversations because those are driving force for how we're going to define at what level we should actually define our data structure. In this also can be store terabytes of data. We don't have to store everything, but if we do one or two things really well, maybe we'll meet some of the basic use cases that actually help us grow.
Well, we know we have to do cohort selection. There are certain use cases we can guarantee. And the cohorts have to include samples, clinical data, and experimental data sets. And they have to return samples, clinical data, and experimental data sets.
Yeah.
So, we can start with a lot of the major cohort selection use cases. And that could keep us busy still for quite a long time.
But why is that a different use case than making any other kind of correlation between experimental data and phenotype data? Because when you do that for making your selection and retrieving those cases or retrieving those samples, or whether you do that for determining some survival analysis associated with some kind of experimental variables, you need the same information in the system.
Agreed.
Yeah. The challenge of
That's why the cohort selection one is kind of hard to. You can't walk around cohort selection because every time you get somewhere, you say, "How am I going to run my survival analysis unless I can select the subset I want to run it against and the variable?" Right. I need that piece to work.
Yeah. Okay, but then it's about the same use case that I explained, like it covers everything.
I don't know. I think it covers the core. So let's say we pick 5 hard cohort analysis examples. Then we don't have to cover everything.
I think the challenge of doing this scientific study example is you need to abstract out some basic operation, like cohort selection is one of them, rather than go into a one-to-one application. Otherwise, you don't have the issue here, right? It's which scientific problem you actually look at. You look at avatar, right? You've got the 5 different avatars carry different things, and then you've got youngster, you've got the everything, looking like nice questions. So I really think about it. I agree with Dan. So it's need to abstract out a couple operations. For example, cohort selection, 41, right? One of them, for example, the whole profile, you retrieve the entire, genome-wide information-wide. If you want that big one, that also could be. You want to see, you want to visualize one particular genome or something. You have to really think about a couple of operations. And rather than just to say we want to go really just do some scientific studies, which is pretty hard.
I've got a question to Ian, because you mentioned that you've got a queue of projects that want you to deliver something. Do you have an idea to how general those use cases are that people are asking for you from you?
Unfortunately, Anthony just walks in the room. Anthony runs that work package, but no, that's what we're trying to do, exactly right, that right now. What is the clinical metadata that we want storing, and what are the analytics they run?
Because
And then again, we also get into the question, some of them want primary data storage, and we're saying, well, we don't want to store primary data, we're only in the business of storing process.
that's a critical question, I think. So
And so, which then helps some of the challenges regarding scale, but that's where we're trying to get to, is what are the questions, what are the different data types, what's the kind of analytics workflow we're trying to get to. We only in the last 3 weeks actually put on 4 of these projects, and so we've got a user workshop coming up. And is it, I think you actually mentioned it quite back row. July. Yeah, so hopefully we're going to get a much better picture of that then. You must be in the same position, working with all the different trade projects.
yeah, we had this discussion this morning, so I think it would really be helpful if we align those analysis and metrics and trade and see what's left and because I think core selection is a good one, I think, in terms of what it demands from the system. But it may not be in phrasing the use case which is most appealing to people who are doing the experiments because they have run their experiments and they want to have results. That's
but our first stage, and I think Serge keeps putting his hand up, so I think that's the question.
My main question is how can you guarantee that scalability will really go through without having a clear test scenario for this? Because we might load immense amount of data in and ready for the search app where we are probably trying to load the atlas data. It looks really very
Well, you can test. So there's the old, trust but verify. So you want to know how something's going to scale, and you're trying to build a system that runs test cases. You need to find a scale test case. It doesn't need to be Atlas data. You really make big test data, but performance shouldn't be something that's surprising because you test everything in one clinical trial with one patient. I'm pretty sure you have a performance problem. I don't even have to tell you what your next step is.
So I guess that was the first sort of the set last sort of like project sort of case here. So obviously this provides a bottleneck. So if you keep trying to think of the code as the API and the app side, and not thinking of the back end where the state is stored and where it's going to be. At some point you're going to face these bottlenecks, and it's not everything. However, you design the API to be so these things pose a big problem.
I think the advantage of designing the API is that if you run into these performance problems, you can now actually replace Postgres, for example, with Hadoop HBase. You just have to stick to the contract, and then you can rerun your tests. So that's the great thing about it.
I think there's a danger actually in naively defining the APIs because the kind of return objects that you're going to create and the kind of queries that you're going to create will be different in the terabyte world than they are in the megabyte world.
Yes, of course. There's no question about it. So we're going to dive in that Wednesday a lot further. So,
sorry.
From a user perspective, if I would make choices and I have to make priorities anyhow, then I would not prioritize the analytic part at first. And I would focus on how to integrate data and make the data available for analytical tools. Because there are many other tools we can use in between before they have it available in this case. But if the first step is wrong, then we may have one of our tools to analyze, but data don't allow it.
Pretty much.
Yeah, so I totally agree with you. I think that was our thought was Serge was going to ask me actually. So, because one of the things we were trying to get a handle on is what are the kettle scripts? What are all the different scripts for different data types we can actually access right now to support? Look, I know that we're trying to get that kind of list, but unless we can get the data into the system, we can't really expose it to the user. So that's that key part there. But then you were talking about being able to do cross-study analysis. How we do ontology management, standards management, I don't know how far you've got in trade, but we've only scratched the surface on this, and I know Bronze and things here. And, these are big issues which we're going to have to deal with disease by disease, and that's a scary part of this.
Well, I think that's the risk and danger of not doing some of the analytics. Because what we found is, we have the FDA.
Yeah.
The FDA brings in a bunch of data, right? We get it all integrated. They think it works. Then they go to do their analysis and they look at the data and they go, the way this data has been loaded, this is 2 or 3 months later, doesn't support the analysis I wanted to do. So if all we want to do is load data in a database, I can do it real fast. Right? Don't worry about structure. Take the data from the Excel spreadsheet, convert it over, call every single column header a table name, and drop any field that doesn't match the data. The problem is that we don't start thinking like the user, especially in these complicated cases where the ontology matters. We're in deep trouble. I'm not saying we have to define every ontology, but we have to define the extensibility model, which, if I was to go through all of our experiences where we get into trouble, it's those extensibility modes. It's when we're saying, I started with a patient, and now I have a sample which has 6 derivative assays. And now this patient-centric model is messy. Or I thought I could describe all of the attributes of the patient in a certain way, but now I want to look across 2 studies, and they handle it differently. Right? And so I think I just want us to stay one layer above. It's just a store. It's a store we're going to do comparative analytics in. Right?
I do have an argument for the focus on the first step as well, because I think that is very poor for everyone who is using it. Well, some of the analytic things are maybe very specific for certain areas.
I mean, the drawback there that I see having been in the data warehousing business is you can get caught in basically trying to build an interface to everything, which is sort of a fool's errand, right? Trying to build an interface to Epic and Cerner, Oracle Clinical and Open Clinica. There is no end to the source systems and the different forms that things will come in. So somebody has to say, that's outside my system. Right? So at least that's the storage. We have to make sure we kind of draw a quick line as to.
But that's exactly what we're trying to do with the biobank metadata, where we've got this intermediate entering exactly the right knowledge. So this common biorepository model is like basically a harmonization on the ontology level, so which is outside the tranSMART.
Maybe then I just try to summarize a bit more your view. What you say that go back to my basic operator concepts, right? We abstract out some of the user cases or scientific story into this case, right? Population. So the other thing with our support in the database is a large population, the comparative study of 2 populations. If the system call can do this kind of operation, is a starting point. Is that right?
Yeah.
So in large population comparative study, right? 2 cohort. And with molecular profile, I can compare. If the core system have the analytical support for this kind of application, that's the direction. A core system though.
I can tell you, we're running the philosophical problem at the architecture level between protocol-driven studies and observational studies. Right? That's where a lot of the it's made it really hard to make one thing that does both these things.
Yes.
Because observational data is like, boom, you have an EMR, a lot of observations. We know exactly what's supposed to be observed. We put in a big ontology, every patient has some kind of longitudinal record. In a prospective study, everything was structured by how they wanted to design their study. Right? And we have to now adapt our whole system to that structure every time, and then we have to align all these studies back and forth. And they're very different problems, but we're expecting, because we're trying to do comparative analytics across a lot of different systems, to deal with both. Which is why I think we should just keep focusing on that problem. Because we're not going to get there fast if we go and get distracted by interfacing every possible system. We're trying to build every possible analytics.
Why is the difference so big? Because you have we have the individuals in there, be it patients or be it healthy persons in some kind of epidemiological cohort, and we may have in time multiple observations on those individuals, and we may have multiple samples on those individuals, and on those samples we have derivatives and measurements. And I don't see why that would really be different for a clinical trial that you're running and you do an exploratory translational science study, or you do that on a retrospective sample set.
I would agree, except if I peeled open the tools we're using and I said, let's look at I2B2, I2B2 doesn't have a field for time point. It has a field for encounter. It has a field for date time. But if I want to line things up with time point right now, we jammed it into the ontology, so we have no place to put it. Now, I'm not saying we don't just fix I2B2 and say I2B2 cover this, and that's what we're going to probably do. But it is a place of consternation and pain. So I think you're right. There's no reason why these shouldn't all be one continuous system, but we're inheriting some legacy stuff from the system we've worked with.
There's also the issue of the data shape, right? So basically longitudinal data looks like this, and then if you have omics study, it's like this. It's pretty deep for a small set of subjects. So.
No, I was going to say that there's a bottom line fundamental differences. So in our hands, anything that looks like a non-longitudinal observational study works pretty well. You can translate. Right? Yeah. And yes, we have to, okay, so we put the system a bit to get longitudinal studies, right? And there's some issues there. Is that fundamentally in terms of clinical translational studies that we're dealing with, that we need a good implementation of longitudinal protocols, or is beyond that?
I think we need a good strategy to build the API and the analytic middle tier to handle both consistently and effectively and predictably when the user's playing the system. Because right now, I'm not sure. Like I honestly don't know. If you play with the longitudinal data and you play with the clinical trials data with the same tool, if you will get a meaningful result with the same analytic tool. I think you won't. I think you'll get it if the tool was designed on the analytic layer to deal with protocol-driven stuff, it'll work. Or if the tool is designed for the observational data, it will work. But the tools that may do exactly the same thing won't work together kind of structure.
I'm kind of lost, and I would like to ask Wim a question, because one thing we've done is that we have patients who participated in a phase 3 clinical trial. All of the clinical data has been prospectively collected according to those protocols as you were just describing them. And we went back to the human samples of those patients and later on ran RCGH on those. So we have following, if I understand you right, we would have everything in there that would go along with a prospective clinical trial. And we have an observation that we did on the sample. And Wim has actually run the use case at tranSMART. So
yeah, but
did you, are you a magician or what?
No, we don't store the longitudinal data.
So what is longitudinal data then? So
for me, longitudinal data is you have a number of observations, maybe similar observations that are timestamped. So you have, in that sense, the observations are as an encounter, but they are timestamped. So you can have multiple observations, like prostate cancer. So you have PSA values. You do multiple of those observations, and you want to make distinct. You want to distinct them, and then because of that they are timestamped. So you have PSA observation, but which one do you refer to? That depends on the timestamp. And for analysis, that's not good. Maybe you want to have an observation that says I need PSA value just after or in first 3 months after prostatectomy. And then it makes sense. And then that kind of observation you want maybe to use in your analysis or to define cohorts. And that's not what
like following cholesterol for patients at risk of cardiovascular disease would be.
I think you can store it in I2B2, but I don't think tranSMART is very well capable of dealing it within the UI.
But here's an example, right? So if you want to say if your longitudinal study can be described in terms of roots, is it 1, 2, 3, 4, 5, and you can assign those. You can plug the system. You can apply a variable. You can say I want to create cohorts. I only want between roots 2 and 5. But if you're dealing with something like ADME, PPMI, where the visits are not, they may have the same number of visits, but they're not necessarily going to be the same time frame for the patients. And now I want 50 days, within, I want to know what my patients were doing between day 50 and day 300 or something of that nature, that becomes much more difficult to describe such that we can make, because it's a number, potentially, but it becomes more complicated to try to devise a query within the Dataset Explorer to get what you need. So I think it's those types of issues that whether, I don't know if it's just purely an interface type of issue that you need, or if it's something that's more fundamental within the context of the data model.
How's ENIF gonna do this?
ENIF? Not just ENIF?
Well, I can start with, these are all very solvable problems.
Yeah.
But part of them are, you took a system that evolved the observational data. So I think it works great with observational data. In fact, until J&J came around, they've probably never even seen prospective clinical trials. Right? So the system that's sitting in there, the structure is well optimized for that use case and purpose. We built an analytical front end that was very specifically oriented to getting the work done inside of a pharmaceutical company to do comparisons within clinical trials. And so we really constrained what you could do inside that UI to make the user's life easier. They wouldn't have to constantly specify, no, this is not observational data every time they drag and drop something. But now that we're trying to do both, because we're going to a different tier problem, we have to go back and look at how that UI binds back to that data and what the interface that the keys wants to make needs to look like. And we have to figure out, do we need different modes the thing runs in? I don't know, different user interfaces possibly for these different tasks.
Or we just need to change the model and do it in Spotlight. No, look, I'm completely serious.
You could do that too, but that would be just using a different interface. You're still gonna have data somewhere.
Right.
It's still gonna get into Spotlight.
Spotlight seems to be just a user interface, right, rather than a storage management.
Right, absolutely. I'm not saying we take transplant out of the picture.
Yeah.
I'm saying that Kirk and Elmer has made a real commitment to the transplant community.
Yeah.
You can leverage, like I saw in one of the presentations today, in Rudy's presentation, where you can leverage something like Spotfire that we may be able to make sense out of these more complicated data.
Yes. But in Rudy's talk, what actually mean is that some function have to be built inside the data model to support it.
That's right. Or right. Yeah. But the idea is that you want to be building interfaces, or do you want to be building a way of getting that data out and putting it into something like Spotfire? And I mean, if the answer is you want to be building a transfer mechanism from tranSMART to Spotfire, and maybe Kirk and Elmer can help us do this, then maybe that's a solution.
But in reality, Jay, the community will go back to core. We'll never build all the functionality in one or two interfaces. So there'll be a core set of interface functionality, basic functionality, and you rely on others in the community, whether using Spotfire or tools to innovate. And that's where you act like a core.
Yeah, and also, I know people who want to see data in IGV. Spotfire's not IGV.
Yeah.
But so there are other people who may want to use Spotfire for certain tasks. It's probably not optimized for biochemical pipelines. It's optimized for doing nice, rapid visual analytics across a cohort of lots of different parameters. So I think we do need to deal with this.
But
Get data to the tool that's supposed to visualize it, and be really efficient at making the selection to get that data, and make sure we don't lose the original intent and granularity of the data in transit because of all the help we're trying to give it. And we haven't spent enough time on it, but we do need to spend time on the security question, because a lot of the business drivers and cases we're dealing with are not within a single enterprise. And as soon as we deal with even inside of a single enterprise, we get into cases of, I want to lock this kind of data from this user. And so even if we use Spotfire can't just go straight up against the transport data.
Yeah.
And so we should start working on that piece as well with a little more priority.
I don't wish to make things more complicated, but talking about Wim's case, maybe for PSA the time span is not very helpful, and we should have something different. But in the same study, maybe disease progression would be very useful to have the time span stamp on. So even within a study, I think you have diversity.
Yes, I was thinking, going back to Dan's point earlier, sort of defining the core. Like maybe as a community we should get together and try to understand what are the strengths of tranSMART today, what is used quite a bit, that would help us define the core.
Yeah.
I believe you said that. I think we do need to consider sort of high data or ladder data the object type that we return may be dependent on the size of the data that we're returning and how we're doing it. Also mechanisms to pipelines like caching or queuing and all of the sort of supporting technology will kind of define the core, what's needed. So I think coming back to Dan's point, I think we should kind of focus on strengths of tranSMART, what solutions are out there are better than tranSMART, analytics. I'm hearing, and this within Pfizer, I'm hearing from our customer, 5-dimensional data, analytics is not strength within tranSMART. What do others think? I think we should focus on thinking about those questions.
Yes. I think it's pretty much we have to really think about going to dinner very soon, so I'm not going to open the discussion forever. But I think if really, we still have 2 more days to discuss about that. But I think from today's discussion, a couple of things will actually quite converge in many opinions. Right? Number one is definitely not build a one-fit-all system. Right? There will be a core, there will be API, there will be API enabling a lot of plugins. That's totally buy-in by everyone. I think now we come to the point about what is in the core, right? That was a lot of discussion coming on. The view which Jerry mentioned very strongly is the core should be defined based on the application, and also mentions what customer need is what we build, right? Cool. But then you come to the next point is how to actually gathering the requirements of what you define, you call scientific story or scientific need. So that's come to probably we needed to do the abstraction, couple of key operations, right? We already mentioned a couple of them today, right? Cohort selection, longitudinal studies, right? Disease progressions, and also probably population-based profiling comparison. That's a quite good operation. And then we look at which operation will be done. In this operation, what core should be supported, in what scale, and then we're thinking about what it can do outside, like by profile. I think that is something we come to the next stage. I'm not going to finish. We're going to debate this one here now, but that's a very technical business convergent question. I never believe the technology and business is separate. It's always joined together, right? And now this is a meaningful discussion will start, right? So what is really the core, right? How we actually build this core? What function inside, what outside? What's the principle defined API? I agree with Terry, absolutely, not really naively think about, whatever API design, every problem solved. Right? It's actually not true. And we really think about what is the basic core data models, and for example, the time point support, you mentioned this one here, right? But I think this will be leading to our next 2 days big discussion. Hopefully, this lot of the feedback will come, and as Ian said, we will on the customer-driven way of design system anyway. So that's a good way. So many discussions can happen in the park anyway, right? Yeah, that's no, you run the show.
Yeah. Okay.
Okay.
We dismissed.
No, thank you very much. You dismissed.
So organizational aspects then, such as where's the dinner? The dinner is planned for 19:30, so that is we still have some time, and it's down the street. So if we exit the building, then I don't know. Some of you planning to go back to the hotels? It's now 18:15, so more than an hour. Probably you are. You have a map. This building is called the VU University Main Building. You walk further down the street, so probably most of you came from the train station. So you go further down the street, and then you'll find the VUMC. It's clearly labeled as 1117 as a number, and that's the entrance for the restaurant. So we'll have some people waiting there outside, so you recognize where to go. And I hope you have my number in case you cannot find it, or Jan's number. Please give me a call. So hopefully see you in a little bit more than an hour at dinner.
Okay. Thank you.
Dit was mijn notebook, geloof ik, hè? Ja, dat kun je wel meenemen. De kaartjes even.
Sometimes it's messy.
Sorry guys, I forgot to mention something. We actually have drinks, and it's in the restaurant. So if you come with me now, we'll have some drinks right before the dinner. Which restaurant? This restaurant or? No, Fiona.